Hello friends and welcome to my channel. Thanks for watching. In today's video I'm going to show you how can we use ArcHydro to create stream network and delineate the watershed boundaries. This video is a continuity of a previous video in which I explained conceptually how the process works. This analysis is a basic of water source management and flood modeling analysis. Please subscribe to my channel if you have not done it before. Let's start our video. We will start with the digital elevation model, which is the fundamental dataset for this analysis. I have a digital elevation model for some area. From here you can see it looks like a mountainous area. The water streams are quite visible. Digital elevation model is a raster dataset, which a pixel based raster dataset whose pixel shows the elevation. The pixel value is basically representing the elevation. In general, it is a 2D data. To view it in 3D, we need to use some software like ArcScene or ArcLog. However, within ArcMap, we can simulate this 2D data into a 3D view. For that, we can calculate a hillshade and we can set the transparency of this data set, and it will be shown as a 3D. Let's check. In the spatial analysis toolbar, we have a surface toolset. Under the surface toolset, there is a hillshade toolset. If we take it, we can select the digital elevation model. It is saying that maybe it is already exists. There is some issue. We can give it any other name. And these azimuth and altitude are basically the sun position, azimuth of the sun and the altitude of the sun from the horizon. We will keep it as a default values. Click. So our hillshade is calculated. Okay, now if we turn it on, we'll see it is showing us more 3D representation. We'll bring it down, and in the dim properties, we first need to change the transparency. If we put it, for example, 30%, it will be apply, and now you see the elevation is quite visible. To make it more readable and more good looking, we can change the color ramp also. These are the different color ramps, but there is a way you can view them as a graphic view or with the names. So right click on the color ramp and then you can select between graphic view or with the name. There is one color ramp under the name of surface. We can use that. It shows the low areas in green and the most highest elevation areas with white color. So now we can see our digital elevation model. Our area is now quite good looking, and now we can see that the high altitudes and the valleys and the streams here. This until up to this point, it is just for viewing purpose. It has nothing to do with our watershed analysis. Now we can start our work using the ArcHydro. As I showed you in previous video, ArcHydro you can download. There are many tools related to the water resource management and the watershed management, but we will not be using and exploring this extension fully. We will be using a certain selected tools. So the first step in delineating the stream network is to fill the sinks. We will go to the dam manipulation, and there is a called fill sinks. I will be using the default values. I will not change anything. Just run that command, and whatsoever the input, it is automatically giving the output name, and the settings you can keep as it is. Click OK. So the flow direction, fill syncs successfully calculated. So now this elevation model that we have created with the name of fill, it does not have any interpolation errors. If there was any peaks, if they are removed, if there are any depression areas, that are also removed. If you want to see those areas, there are some commands that you can find things in special analyst also, and in the ArcHydro you can identify those pixels which could be error. Now the next step is to calculate the flow direction as I explained. So I will take again the same default value, click OK. So these are our flow direction as I explained in the video. This raster pixels range from value 1 to 128. This is a code in the power of 2 raised to power in the binary coding. So 1 mean 2 raised to power 0, and it is true east, and 128, it is a complete round the clock northeast corner of a pixel. So if we turn it on, we will see that it has given a code to every pixel. After that, we will calculate the flow accumulation. Flow accumulation will show that where most of the water will flow in which pixel. So it will code accordingly that how many pixels will be draining into this pixel. So calculate. It is calculated. So this is our flow accumulation. From flow accumulation, basically the stream network becomes quite visible. So this will be, actually this is just a reclassification of the image. We can also do it manually, and this is just doing the reclassification of the raster and converting it into this coding. Now from this we can generate the streams that are in processing. After flow recovery, there is a stream definition. Here in ArcHydro, by default, here we need to change the values. In ArcHydro, it takes the 1% of the total pixels by default. Number of cells, you can, what does it mean, the number of cells? It means that how many cells you are analyzing to calculate one stream. So if you want to a very detailed stream network, you need to take a smaller area, or if it's like mountainous, there is a lot of curvature, you can generate the streams very detailed. But in the plain areas, maybe you need to take a bigger area to make a stream. You can test, it depends on your area and the resolution of your digital elevation model. You can test do some experimentation, and then you can reach an optimal value. Here I'm going to use a 300 pixels, which are corresponding to around 0.75 square kilometers. We'll generate the stream. It is done. So if we see here, it is in the form of 10. These are our stream network. There are tools to make them ordering of these streams. What does it mean, the ordering? In hydrology, they use the stream order. The first order streams are those streams, the smallest stream from where the stream is starting, and then it keeps on becoming the bigger up to the river or the output area of that watershed. In ArcGIS, there are two methods of stream ordering. I will explain it in the next step. Still, these streams are in raster form. We can make them into vector and then we can run the stream orders. So our stream network is in raster form. It has been generated. Next, we can make them as a segmentation. Segmentation means based on the watershed, it will be given some unique ID. This is the requirement for the watershed delineation. It is called the stream link in ArcGIS. In ArcHydro, it is what they call it stream segmentation. So we click. Basically, it will be the same stream network, but it will be having some unique IDs for everything, for all the stream. Next, we can catchment grids. So the catchment grid, it will delineate the area where it is, from where the water is coming into it. So catchment grids, it will call catch, and its input is the link grid that we have just created. It will generate a polygon. So if you see, these are the areas of catchment of each stream. It is a raster data. We can convert it into we will convert it into vector catchment grid delineation, and after that we can make it as a polygons. So if you see here, our polygons are generated, and if we bring them down, so zoom in, we can see that every stream segment has been drawn as a catchment. This is the catchment of every stream segment. This is too much detail. We can dissolve it to make it bigger catchments, and also now we can convert our stream into the vector. So we need to save it. We can save our document. I will say it as a flood modeling mxt. Save. And now if we run the stream network, drainage line processing, drainage line, and click OK. So now our streams are in vector format. If you see here, I will close this. So if you identify, this is a vector data now. There are some automatically generated attributes. You can also add now your own attributes, and you can, this is our stream network. So how can we create the ordering to make it more, right now they are having the same order, but we can use different order. We will use hydrological toolset in Spatial Analyst. Under the Spatial Analyst, there is a hydrology toolset, and here is the stream order. What it is taking, input raster, stream raster. So we can take streams, and then the input flow direction. We'll take the input flow direction FDR, and output, it is giving us error. Let's gives some issue with the geodatabase I'm using. I will call it stream ordered. No. So here I will explain you the what is the stream ordering. There are two methods that ArcGIS use. One method is called Streller and other is called Shreves. So what are these methods basically? In the Streller method, the stream ordering work in a way. If you go to the ArcGIS Pro help or ArcGIS desktop help, you will find this documentation there. In Streller method, the magnitude of the stream, the first order streams, when they meet, where if they have the same magnitude, they will add up and becomes 2. Now when this 2 will meet with order 1, it will still remain 2. But when this 2 and 2 will meet again, it will become 3. So when the magnitude is same, the order is increased by 1 step. This is called Streller method. But in Shreves method, they keep on adding. Wherever a stream junction happens, it added up 1. For example, here we see 1 into 1 becomes 2, then 2 into 1 becomes 3, 3 into 1 becomes 4, and on this branch we get 3, 4 into 3, the 7. So our main channel is having the stream order of 7, whereas in Streller method it is 3. Most of the researchers use Streller most, and it is the default of ArcGIS also. I will prefer to use this method also. But you can, depending on your requirements, you can select any method. So here the method of stream ordering, we will take Streller and click OK. Our stream network in the form of I will switch other also. With the stream orders, if you see here, we have up to 5th order streams from 1 to 5. We can change its symbology. We can use the stretched value and use a single color. So from here you can have your, so it is again, it is a raster data. You can convert it into the vector. Stream to feature. Input stream raster. I will use the stream orders, and then the input flow direction, FDR, and here it will generating the shapefile. We can give stream network, simplify the polylines. Okay, now the same network we got into the vector form. We can go to the symbology. By quantities, we can say the graduated colors or graduated symbols using the grid code, ArcID. So you can see with the order 5, from 1 to 5, we can use the watercolor as blue, and we can also use some dotted if you want for the first order. And change the color to blue. So from here you can see this is our stream network, and first order, and based on the order you can use the different color if you want. And if now we turn on our elevation model with the Hillshade, you can see it is a very good looking analysis. From here we can see how the water will flow naturally on this surface. For the flood modeling, you need to use some other parameters like the soil type, and if there is any construction, man-made activities, if there is any these kind of parameters, and then you can set some threshold to make it a complete flood modeling analysis. And this is how the drainage can be calculated from the digital elevation model.